calculation of CG coefficients for J1 and J2 both equal to 1 by 2. We know that when we add the two angular momentas, if J is the total angular momentum F and M is that state, then that state with J1 and J2, which is given to as 1 by 2 and 1 by 2, whatsoever is its value, that is given by this expression. And then in this expression, these coefficients are called CG expansion coefficients. By looking at this expression, we can say that these are the expansion coefficients when we convert the state or when we relate the state Jm with the state M1, M2. Given J1 is 1 by 2, for J1 is equal to 1 by 2, M1 can have value 1 by 2 and minus 1 by 2. Similarly, for J2 is equal to 1 by 2, M2 can have value minus 1 by 2 and minus 1 by 2. Now, the rules for CG coefficient is that M, that is after the addition of angular momentum, M can have the value M1 plus M2. Only this state is allowed state. And the total angular momentum J will have the values from J1 minus J2 to J1 plus J2. The CG coefficients are real. These are the properties of CG coefficient. Now let's calculate CG coefficients for J1 and J2 equal to 1 by 2. Let's see what are the possible states with J1 is equal to 1 by 2 and M1 can have these values and J2 is equal to 1 by 2 and M2 can have these values. The possible states are 1 by 2, 1 by 2, 1 by 2 and 1 by 2. This is the state I am writing J1, J2, M1 and M2. This next is, this can have value 1 by 2, 1 by 2, M1 can have value minus 1 by 2 and 1 by 2. Third state will be 1 by 2, 1 by 2, minus 1 by 2, minus 1 by 2 and 1 by 2, 1 by 2, or if we write down plus first, then it will be plus 1 by 2 with minus 1 by 2 and then minus 1 by 2 with minus 1 by 2. These are the possible states. M1 will have value 1 by 2 and minus 1 by 2. M2 will have value 1 by 2 and 1 by 2. M1 will have 1 by 2 and minus 1 by 2, minus 1 by 2, minus 1 by 2. These are the four possible states. Now with these four possible states, the total angular, when we add the two angular momentas, then M1, the J will have value between between J1 minus J2 and J1 plus J2. That is, J will have value 1 by 2 plus 1 by 2. That is 0, J and 1. J can have two values, 0 and 1. These are the possible values of J. With these possible values of J, let's see what are the possible states J1, J2, M1 and M2. Rather, for CG coefficients, we will say J1, J2, J and M. For J is equal to 1, M can have value minus 1, 0 and 1. For J is equal to 0, M will have value 0. So the four possible states, we also know, otherwise also, the dimensionality, the total possible values are given by 2j plus 1 multiplied by 2j1 plus 1 into 2j2 plus 1. So we will total have 2j1 plus 1 multiplied by 2j2 plus 1. This will be the total possible states. So we will have 2 into 1 by 2 plus 1 into 2 into 1 by 2 plus 1. That is 2 into 2. So four possible states are there. Let's see what are those four possible states. Let's write down the states J1, J2, then Jm. So corresponding to J is equal to 1 and then corresponding to J is equal to 0. The possible states are 1 by 2, 1 by 2. With J1, M can have value 1, 1 by 2, 1 by 2, 1 and 0, 1 by 2, 1 by 2, 1 and minus 1. And the fourth possible state is 1 by 2, 1 by 2, 0, and M will have value 0. For convenience, I am writing it, denoting it only by Jm. J1 and J2 understood that they are 1 by 2, 1 by 2. So this state I will be denoting by 1, 1, this by 1, 0, 1 minus 1, 0, 0. Remember, now these are Jm states. Now our aim is to relate these Jm states with M1, M2 states. In the beginning, I said that this Jm is given by summation of all these. These are the expansion coefficients. So expansion coefficients, we know that any state alpha, generally speaking, any state alpha can be written as C dash, A dash. These are the expansion coefficients. Let's first of all, let's try to write down these states. These states will be one state. This is related, all these states are related to M1 and M2 states by unitary matrix. That is, if I write down these states in the matrix form, then I can write down that 1, 1, 1, 0, 1 minus 1 and 0, 0. These states are related to the M1 states, M1, M2 states by, these are the M1, M2 states. This we'll see what corresponds to it. And here the transformation matrix, which is unitary. And this transformation matrix is nothing but a matrix which is representing all the CG coefficients. And this is a unitary matrix. The unitary matrix, it will be 4 by 4 matrix in this case. And the equation is written as Jm is equal to C M1 M2. This one state corresponds to 1 by 2, 1 by 2 M1 M2 state. This 0 state corresponds to 1 by 2 minus 1 by 2 state. This corresponds to minus 1 by 2 minus 1 by 2 state, and this corresponds to minus 1 by 2 and 1 by 2 state. Now our aim is to calculate, to see this unitary matrix. Let's see how we will be getting this unitary matrix. The state, for the convenience, just to overcome the confusion, I am denoting this Jm state by psi state. That is, I will be writing psi Jm, and the M1 M2 state, which is once again J1 J2 M1 M2, this state by phi state, phi M1 M2. So this is just to overcome the confusion, because I will be writing only the values of Gm and M1 M2. J1 J2 are understood as 1 by 2 1 by 2. First of all, let's consider the states. The first state was 1 1 state. Now 1 1 state, it can be expanded, and it will be expanded in terms of the 4 states. Those 4 states are the M1 M2 states. Those 4 states are 1 by 2 1 by 2, 1 by 2 minus 1 by 2, minus 1 by 2 minus 1 by 2, minus 1 by 2 and 1 by 2. Let's write down, expand this 1 1 state in terms of these 4 states. So 1 1 state will be, it will be written as, 1 1 state can be written as, let's keep it here. This will be first expansion coefficient, say C1. 1 by 2, 1 by 2, C1 dash plus C1 double dash 1 by 2 minus 1 by 2 plus C1 triple dash minus 1 by 2 minus 1 by 2 plus C1 4 times dash minus 1 by 2 and 1 by 2 state. Similarly, we will be writing all the 4 states. This next is, this is Jm, remember this is Jm and this is M1, M2. So, once again, to overcome the confusion, let's put psi here and phi here. So, the next psi state is 1, 0. This will be C2 dash phi 1 by 2, 1 by 2 plus C2 double dash phi 1 by 2 minus 1 by 2 plus C2 triple dash minus 1 by 2 minus 1 by 2 plus C2 4 times dash minus 1 by 2 and 1 by 2. The third state is 1 minus 1. This will be written as C3 dash phi 1 by 2, 1 by 2 plus C3 double dash phi 1 by 2 minus 1 by 2 plus C3 triple dash minus 1 by 2 minus 1 by 2 plus C3 4 dash minus 1 by 2 and 1 by 2 state. The last state possible is psi 0, 0. This will be C4 dash phi 1 by 2, 1 by 2 plus C4 double dash phi 1 by 2 minus 1 by 2 plus C4 triple dash phi. Here once again I have missed phi, so let's write it down. Phi minus 1 by 2 minus 1 by 2 plus C4 phi minus 1 by 2 and 1 by 2 state. Our aim is to calculate these coefficients, these expansion coefficients. They are called CG coefficients. So we are to calculate all these 16 coefficients. Let's go back and see what are the possible states. Let's consider the first equation. In first equation, it is Jm. So m is 1. We know that only those states are possible where m1 plus m2 will be equal to 1, that is 1. So for the first state, let's see which state is possible. This state is 1 by 2 and 1 by 2. That means m1 plus m2 will be 1. So this is existing state. It is 1 by 2 minus 1 by 2. m1 plus m2 will be 0. So it is not possible. It is minus 1 by 2 minus 1 by 2, not possible. This is not possible. So we have psi 1 1 will be equal to C1 dash phi 1 by 2 and 1 by 2. Remember, this is Jm, don't get confused, and this is m1 and m2. Let's name it. Let it be number 1. Next is psi 1 0. In this equation, in this state, m is 0. So if m is 0, only those states are possible where m1 plus m2 will be 0. Here m1 plus m2 is 1, m1 plus m2 is 0, m1 plus m2 is minus 1, m1 plus m2 is 0. So that means these two states are possible. So we will have this to be equal to C2 double dash phi 1 by 2 minus 1 by 2 plus C2 4 times dash minus 1 by 2 and 1 by 2. Let's name it as second equation. Let's consider the third equation. Third equation is psi 1 minus 1. Here the value of m is minus 1. It is minus 1. So in the above equations, let's see which value of m1 plus m2 is minus 1. First it is 1, it is 0, it is 0. No, it is minus 1 and it is 0. So that means only third is possible. So we will have C3, 3 dash, 5, minus 1 by 2 and minus 1 by 2. Let's name it as the third equation. Last is psi 0, 0. Now m is 0. Here it is 1 by 2, 1 by 2, 1. It is 1 by 2 minus 1 by 2, so 0. This is minus 1, this is 0. So that means the second and the fourth states will exist. C4 double dash phi 1 by 2 minus 1 by 2 plus C4 4 times phi minus 1 by 2 and 1 by 2. Let's name it 4. Now we are left with only these coefficients. If we look at the equation number 1, it is understood that C1 dash will be equal to 1. So we have calculated it. And similarly, in the third equation, C3 triple dash will be equal to 1. 100% contribution of this state only. 100% contribution of this state only. Now our aim is to calculate. We are left only with these 4 coefficients. So we will be calculating these 4 coefficients now. To calculate these coefficients, we will be using the properties. The first property which we will be using is we have to get the value of state 1 minus 1. We have got the state 1, 1. Let's use the properties of addition of angular momentas and all. We have got the state 1, 1. If we apply ladder operator on this state, that is, I apply J minus, decreasing operator. This J minus, if this J minus acts on the state 1, 1, it will not affect J, but it will decrease the value of M by 1. So that means this M state will become from 1 to 0. So that means if I apply J minus operator on state psi 1, 1, I will get the state as psi 1, 0, and along with it in the units of h bar only, the value which I will be getting is j plus m into j minus m plus 1. This is one thing. So that means if I apply j minus operator on 1, 1 state, I will be getting this value. I also know that this j minus operator, this is equal to j1 minus plus j2 minus. That means on the left hand side I have got only the value of j and m. On the right hand side I have got the value m1 and m2. So that means if j minus operator acts on the state which is m1 and m2, then that is j1 minus plus j2 minus acting on the state m1 and m2. When j1 minus 1 minus operator acts on the state m1 m2 plus I can write down j2 minus acting on m1 and m2. Here j1 minus operator will affect the value of m1 only and j2 minus will affect the value of m2 only. That means here it was, if it is, I am writing it with the phi, so if it is phi, so that means this phi state will become, along with the coefficient which is there, which is j plus m into j minus m plus 1 into phi, and phi here I will have m1 minus 1 and m2 plus, along with the coefficient which is which is j plus m into j minus m plus 1 into phi m1 and then m2 minus 1. So that is how it will act on the right hand side. Let's see how we'll be getting it. We have the state psi 1 1 and it was c1 dash phi 1 2 1 by 2 and 1 by 2. Remember, it is jm and it is m1 and m2. Let's consider the left hand side first. Left hand side is psi 1 1. Let's operate j minus operator. We will get j minus operator acting on state psi 1 1. This will make this state as psi 1 0. And let's see what will be the value along with it. The factor which will be multiplied to this will be j plus m into j minus m plus 1. So here j is 1 and m is 1. So I will be getting under root 1 plus 1 into 1 minus 1 plus 1 into the state psi 1 0. So it will be under root 2 psi 1 0. This is the left hand side. Right hand side will be, right hand side is what? It is c1 dash. c1 dash we have already calculated. It is 1 only. Phi 1 by 2 1 by 2. So it is phi 1 by 2 1 by 2. Let's operate j minus on it. J minus acting on phi 1 by 2 1 by 2. This is equal to, it is m1 and m2, so that we do not get any confusion. We are not trapped in a confusion. So it will be j1 minus plus j2 minus operator acting on state phi 1 by 2 1 by 2. That is j1 minus phi 1 by 2 1 by 2 plus j2 minus phi 1 by 2 1 by 2. This j1 minus will affect only 1 by 2 and this j2 minus will affect only m2. The value I get will be under root j plus m into j minus m plus 1. The state will change by, it will decrease by 1. So 1 by 2 minus 1, the state will become minus 1 by 2 and 1 by 2 plus j2. So it will be, I can write it down 1 1 1 1 here, j2 plus m2 into j2 minus m2 plus 1, and the phi state, there will be no effect on m1 but m2 will decrease by 1. So it will be minus 1 by 2. Here j1 is 1 by 2 and m1 is 1 by 2. 1 by 2 plus 1 by 2 1. 1 by 2 minus 1 by 2 will get cancelled. So I will have 1 into phi minus 1 by 2 1 by 2 plus 1 by 2 plus 1 by 2, once again 1 into phi 1 by 2 and minus 1 by 2. So the state will be, when j minus operator acts on phi 1 by 2 1 by 2, I will be getting phi minus 1 by 2 1 by 2 plus phi 1 by 2 minus 1 by 2. Let the earlier it was, let it be a and let it be b. Equating a and b, I will have under root 2, it was, a is this, under root 2 psi 1 0, this will be equal to phi minus 1 by 2 1 by 2 plus phi 1 by 2 minus 1 by 2, or psi 1 0 state will be equal to 1 over under root 2 phi minus 1 by 2 1 by 2 plus 1 over under root 2 phi 1 by 2 minus 1 by 2. Let's name it as equation 5 and compare it with the equation which was already there. We were having these four equations, and here we see that psi 1 0 is equal to C3 double dash phi 1 by 2 minus 1 by 2, and it was C2 double dash phi 1 by 2 minus 1 by 2, C2 4 times dash minus 1 by 2 and 1 by 2. And here we have got the same states, minus 1 by 2, 1 by 2 and 1 by 2, 1 by 2. The coefficient of this minus 1 by 2, 1 by 2 state is C2 4 times dash, which is, here we get 1 by under root 2, and the second coefficient is also 1 by under root 2. So now we are having C2 double dash as 1 by under root 2, and C2 4 times dash is also equal to 1 by under root 2. We have calculated these two coefficients also. Now we are left with only these two unknown coefficients. This is 1 by under root 2, 1 by under root 2, this is 1. Now we are to calculate these two coefficients. To calculate these two CG coefficients, we use the property of orthonormality of the states. We know that all these states are orthonormal. Let's calculate these two coefficients by using this property. That is psi 0 0 is orthogonal, and the two states are orthogonal. We know that. Any two states, they will be orthogonal and they are normalized. If we are to use that property, let's see. To calculate these, the state psi 0 0, we use the property that the state psi 0 0, which is already with us, psi 0 0, this is C 4 times double dash phi 1 by 2 minus 1 by 2 plus C 4 times C4 4 dash phi minus 1 by 2 and 1 by 2. This is the state, and we know that we use the property that this is normalized, and we use the property that this psi 0 0 state is orthogonal to the other state, which is psi 1 0. We know that psi 1 0 we have already done. We have calculated these two coefficients, and psi 1 0 is equal to 1 over under root 2 phi 1 by 2 minus 1 by 2 plus 1 by under root 2 phi minus 1 by 2 and 1 by 2. We have calculated, just now we calculated these two coefficients. Now these two states are orthogonal. If the two states are orthogonal, if alpha and beta, they are orthogonal, then their inner product must be equal to 0. We use that property, and by using that property, we write down that state inner product of 1 0 with 0 0. This is equal to 0. So left hand, this is the left hand side. Let's see what will be right hand side. We write down inner product of 1 0 with 0 0. This is j dash m dash. This will be C4 double dash. The state will be bracket vector of this will be 1 by 2 minus 1 by 2 into 1 by 2 minus 1 by 2. Sorry, let's write it down first. Psi 1 0. Psi 1 0. Let me do it. Let me repeat this step. It is 1 0 and 0 0. This will be equal to inner product of this state with this state, that is 1 by under root 2. I write down phi minus 1 by 2, 1 by 2 plus 1 by under root 2 phi minus 1 by 2, 1 by 2 multiplied by C4 double dash phi 1 by 2 minus 1 by 2 plus C4 4 times dash phi minus 1 by 2, 1 by 2. Let's open the bracket. I will have, this will be equal to, first of all multiply this by this. I will have C4 double dash over under root 2 inner product of my, I am omitting phi here, it is understood, minus 1 by 2, 1 by 2 with 1 by 2 minus 1 by 2 plus C4 double dash over under root 2 minus 1 by 2, 1 by 2 with the 1 by 2 and minus 1 by 2. Third term will be C4 4 times dash over under root 2 inner product of minus 1 by 2, 1 by 2 with minus 1 by 2 and 1 by 2 plus C4 4 times dash over under root 2 inner product of minus 1 by 2 and 1 by 2 with minus 1 by 2 and 1 by 2. Now this is what? This is the inner product of M1, M2, M1, M2, M2 dash. So inner product, this can be defined. We know that this inner product, if I write it down, inner product of M1, M2 with M1 dash, M2 dash, this will be equal to delta of M1 with M1 dash and delta of M2 with M2 dash. This will be 1 when M1 is equal to M1 dash and M2 is equal to M2 dash. Otherwise, it will be 0. Let's see how it acts on this. In this state, M1, M2 is minus 1 by 2, 1 by 2. M1 is minus 1 by 2, M1 dash is 1 by 2. So delta of minus 1 by 2 and 1 by 2, this will be 0 and delta of this will be also 0. So the first term comes out to be 0. Second is, let's see, it is minus 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. So second term will also be 0 plus C4 4 times dash over under root 2 delta of M1 with M1 dash minus 1 by 2 minus 1 by 2. So delta M1 M1 dash is 1 and delta M2 M2 dash is also 1. So this will be multiplied by 1. It will be delta of minus 1 by 2 minus 1 by 2 and delta of 1 by 2 1 by 2, which is 1. So it will be C4 4 times dash over under root 2 because this term will be 1 only. Similarly, this will be 1 and we will have C4 4 times dash over under root 2 into 1. So you get C4 4 times dash over under root 2 plus C4 4 times dash over under root 2. And the other side, the left hand side is 0. So that means we will have C4, it was here, I have written one thing wrong. It was C4 double dash with this. The one will be C4 double dash and the second will be C4 4 dash. C4 4 times dash. This will be 0. You just multiply, check. It will be C4 double dash at one point and C2 double dash at one point. So I will have, here it was 2 times and then it was 4 times. So 2 times and 4 times. So you get C4 double dash will be equal to minus C4 4 dash. To calculate this value, we use the normality condition. Normality means that inner product of state 0, 0 with itself will be equal to 1. If you multiply this, we will be getting the state C4 double dash modulo square inner product of 1 by 2 minus 1 by 2, 1 by 2 and minus 1 by 2 plus C4. C4 state was, we had only these two, 1 by 2 minus 1 by 2 and C4 4 times modulus square inner product of minus 1 by 2 with 1 by 2 minus 1 by 2 and 1 by 2. This is equal to 1. So from here we get C4 its square plus this is 1, this is 1, C4 4 times this modulus square, this will be equal to 1. Or we know that they are equal with the opposite sign. We have just calculated. So we get C4 double dash modulus square plus C4 double dash modulus square will be equal to 1. That is 2 times C4 double dash square is equal to 1, or C4 double dash is equal to 1 by under root 2. So therefore C4 4 times dash will be equal to minus 1 by under root 2. Now we have calculated these two also. Let's see now what we have. We have the equation psi 1 1 will be equal to phi 1 by 2 1 by 2. This is J and M. This is M1 and M2. Psi 1 0 will be equal to 1 over under root 2 phi 1 by 2 minus 1 by 2 plus 1 over under root 2 phi minus 1 by 2 and 1 by 2. Psi 1 minus 1 will be equal to 1 into phi minus 1 by 2 minus 1 by 2. And psi 0 0 will be equal to 1 over under root 2 phi 1 by 2 minus 1 by 2 plus minus 1 by under root 2 phi minus 1 by 2 1 by 2. Let's write it down in the matrix form. In the matrix form, in the beginning, as we said that the states are Jm, I defined the matrix. It was Jm here. So Jm state will be it will be 1 1 1 0 1 minus 1 0 0. here the first coefficient was, it was the coefficients, the 4 states which we had are it was 5, 1,